To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Right, my dear children. Now, in the earlier chapter, I told you that we are going to carry out several other experiments in order to find out somewhat more things related to the plane mirror reflections. Now, within this chapter, with the start of the second chapter over here, we are going to discuss another activity regarding the plane mirror reflections, right? So, once again, we are going to experiment how light rays are get reflected from a plane mirror. So, my dear children, within this activity also, you will be needing these materials. So, we will be needing A4 sheet, white color A4 sheet, then a plane mirror, then some pins, a ruler, then to draw the ray diagram, pencil, then to measure the angles, protractor, and then over here we'll be needing a stand. So we'll be using the stand. You know that we have to place the plane mirror perpendicular to the white color surface or to the A4 sheet. No. So that's the main reason or the whole reason of using this stand, right? So these are the materials you will be needing when carrying out this experiment. So you'll be needing an A4 sheet, a plane mirror, some pens, a ruler, pencil, protractor, and a stand. Okay, right. So let's see how to do this activity then, our method. So as you can see, the figure is given right now. Place the sheet of paper on the table and place the plane mirror perpendicular to the paper using the stand. Then draw the mirror line on the paper. So like in the same way which we did in the previous activity, you have to place the white color surface or the A4 sheet, and perpendicular to it you have to place the plane mirror, right? Then my dear children, remember you have to draw the line of the mirror. Okay, you have to draw the line of the mirror surface. Then the next one, fix two pins in front of the plane mirror which should be on an inclined straight line to the mirror. Observe the images of the pins through the mirror. Now what do you have to do? You have to place two pins at a certain angle towards the plane mirror. Then you have to observe the images of those, right? Fix another two pins on the paper which are in line with the two images. And now what do you have to do? You have to check the mirror surface, then along that line, according to the image which you can see on the mirror surface, you have to align another two pins. Okay. Then my dear children, draw straight lines connecting the pin marks. Now what do you have to do? You have to, when you are doing this thing, you can even remove the things, because you know that when you are marking the pins, there are certain marks, there are certain holes, so you can draw the diagram or the ray diagram by using it without any trouble, right? So here it is given. Fix another two pins on the paper which are in line with the two images. Okay, then what you have to do? Now remove the pins and the mirror. Okay, you have to remove the pins and the mirror. Draw straight lines connecting the pin marks. So you have to draw the, right? Now what do you have to do? You have to draw the line connecting the pin marks. Okay, next one. Complete the ray diagram by constructing the normal line at the point here, it should be at the point of incidence, right? at the point of incidence. In your textbook also the same thing can be observed. So complete the ray diagram by constructing the normal line at the point of incidence as done in activity before. Measure the angle of incidence and the angle of reflection. So what do you have to do? Now you have to remove all of those things. You have to join the lines. You have to mark the straight lines. Then towards the mirror also, you have to join it. Then after that, what do you have to do? You have to take that other side. Once again, you have to join it and you have to mark it towards the mirror once more. Okay. Then by that way, we can complete the ray diagram, right? So this is the way of doing the activity, my dear children. It's pretty much simple. What you have to do? You have to use several pins in here. Now, according to the reflection which is going to come from the mirror surface, we are going to align several pins. Then, my dear children, what you have to do? Then you have to get the ray diagram related to it, right? By using those, like holes. We can join those holes by using the ruler and the pencil. Then we can draw the ray diagram, particular ray diagram, which is going to happen, or which is going to give out from this reflection. Okay, so it's very simple to do, right? So now let's head on to the laboratory. We'll do this experiment, and once again we'll measure out the two angles, the angle of incidence and the angle of reflection, and let's see whether those things are getting equal or not. So my dear children, within this activity we'll be using several pins, and using these pins we'll be conducting the same activity like in the previous occasion. We're going to find out the reflected ray and the incident ray, and once again we are going to draw out a normal and to find out the angle at the either sides of the reflected ray and the incident ray. Okay, so within this activity we'll be doing the activities in some kind of a different way. We are not going to use a laser beam or any kind of thing like that. However, we'll be using the reflection of the reflections or the images created by one pin, right, in order to get the reflected ray and the incident ray. So here we will be using pins. So what you have to do is you have to direct the pin like this in a position, like in an angular position. But however, before that, my dear children, you have to draw out the mirror line like this. So this is the mirror line now. Okay, so in this, like in the same activity which we did earlier, right, we have the instruments with me. Instead of the laser box, I have several pins with me right now. So what you have to do, you just point one pin like in an angular position. Don't make it like direct come in contact with, like, you don't pin this thing directly towards the mirror like this, but make it into an angle like this. Okay, now as there are plenty of light in the environment, we won't be able to observe the image created by the pin or the shadow of the pin. So there are like several shadows over here, so we won't be able to connect the second pin by using the image or the shadow of the first pin which I have pinned over here. So what you have to do is, now what I'm going to do is I'm going to reduce the light amount or the amount of light in the environment. So by that way I'm going to take out a shadow of the first pin. Then on the shadow of the first pin I'm going to keep the second pin, right, so that they would lie on a straight line. Okay, so we'll reduce the light, and on the shadow of the first pin we'll pin out the second one. Okay, right, as you can see here, my dear children, this is the first pin. Now we have darkened the room, so upon darkening, you know that we can clearly observe the shadow of the first pin. So what you have to do is you have to insert another pin, right? You have to insert another pin along the shadow of the first pin. So this is the first pin. Along this shadow, you have to insert another one. So carefully I'm going to insert another one. Here we go. Right. So, right. Now, as you can see here, now this is the first pin. This is the second one. So, this line is a now straight line. Right. So, my dear children, now you can see from the other side, see from this side, the reflection of the shadow is now coming from the mirror, like this is the one. So along that line, now we have to insert one pin like this. Right. Now another one in the same shadow like this. Okay. Now we have to complete out the ray diagram, right? So this is the line which is coming towards the mirror, or this is the incident ray. Now this is the line which is going after the reflection, so that's the reflected ray. So this is the mirror surface, my dear children. Now we'll take this thing out and we'll complete the ray diagram by using these lines. Then after that, we'll draw out a perpendicular and let's observe what's going to happen with the two angles. Right. So my dear children, as you can see here, these are the two pins which I have inserted as the incident ray. So these are the two pins which I have inserted as the reflected ray. Now it's time to draw out our ray diagram related to the reflection. So we'll take this thing out gently and we'll draw out the ray diagram now. So we have marked the, as you can see here, I have marked out the line of the mirror, plane mirror, right? So now we have to take this thing out very gently and we'll draw out the ray diagram. Remember, when you are taking this thing out, it's very important not to move these pins, otherwise the straight line will not be accurate. Okay, right? So we'll take this thing out and we'll draw out the diagram. So my dear children, now this is our board that has the pins. So what I'm going to do is I'm going to gently remove these pins. Let's take the white cardboard out, or the A4 sheet here. Keep it in here. So now we have to complete the ray diagram by using these dots joining towards the mirror surface. So this is the mirror surface, my dear children. So I'll dark the area to indicate the darker area of the mirror. So this is the darker area. Over here, this was the reflective area. Now we'll draw out the ray diagram. Light ray which is coming towards the mirror, incident ray. Light ray which is reflected, the reflected ray. Then we'll use the set square to draw the perpendicular line. So I'm going to mark 2 points, then by using the ruler I'm going to complete the perpendicular line, my dear children. Here we go then. So when you are drawing these lines, you have to be very careful to be very accurate. Otherwise, your readings will get faulty, right? So this should be done in a very serious and a very patient manner. Okay. Now let's measure the two angles. As you can see here, it's very clear to us that this is the 90-degree perpendicular. This is the mirror surface. The 90-degree perpendicular. This is the mirror surface. This angle indicates the angle between the incident ray, and this was called as the normal. I think you could remember the normal. So incident ray, and this is the normal. So angle between the incident ray and normal is here it is 90. So this is 10, 20. That means 20 degrees. Exactly at 70. From 70 to 90 there are 20 degrees. Then here from 90 to 110. Can you see that? From 90 to 110. From 90 to 110. Once again there is 20 degrees. So this is the angle between the normal and the reflected ray. So once again we could get the same observation and the conclusion. It's very clear to us that always in a reflection, my dear children. So this reflection is quite important, because we have reflected the light rays by using a plane mirror. So in a plane mirror reflection, you can clearly observe that the angle between the incident ray and the perpendicular drawn to the surface of the mirror at the point of reflection. So this was named as the normal. So the angle between normal and the incident ray is equal to here the angle between normal and the reflected ray. So it's very simple to us that, or else it's very obvious to us that from this activity, from these two activities actually, we can see that, or we can prove that, we can finally come into a conclusion that always the angle between the incident ray and the normal is getting equal to the angle between the reflected ray and the normal. So once again we'll head on to the classroom, my dear children, and we'll write down our observations and the conclusions. Right, my dear children. So once again you could clearly observe that the angle of incident is getting equal to the angle of reflection. Once more you can observe the same procedure or the same thing, right? So we can write down our observations. Quite simple. Observation: the two angles are equal to each other. So our conclusion is quite simple once more. The angle of incidence is equal to angle of reflection. Right? The angle of incidence is equal to angle of reflection. So this is our final conclusion then, right? Right then. So my dear children, by doing both of these activities, we can come into a conclusion. We have come into a conclusion that always during a reflection, you can clearly observe there is a similarity. So that similarity is always the angle of incidence is getting equal to the angle of reflection. Okay? Angle of incidence is getting equal to the angle of reflection. So I think I have introduced you the components that can be identified within a ray diagram. Over there we discuss about the normal, incident ray and the reflected ray. So you know that angle of incidence and the angle of reflection is the angle between incident ray and the normal, and then angle of reflection is the angle between reflected ray and the normal. Okay, so I'm not going to talk about those things once more. right? So this is the conclusion that we can come into by doing this activity. Okay, right then. So now let's head on to see what are the other things contained within the lesson. So now, my dear children, right, we did two activities related to the reflection process, which is going to happen through a plane mirror. Now we can come into a certain law regarding the reflection. So within this part now, we are going to focus about the laws of reflection. Like what kind of a law or what sort of a procedure that the reflection is going to follow when a certain reflection is going to happen from a certain surface, right? So these things are the ones which are referred as the laws of reflection. So we have even identified one law regarding the reflection. So that law is very simple. Always the incident angle is getting equal to the reflected angle. Okay, so let's see. The observations of the activities can be summarized as follows. Observations from both the activities that we have carried out can be summarized as follows then. Let's see. When light is reflecting, that the incident ray, reflecting ray and the normal line are in the same plane. It's quite simple. You know that the reflected ray, the incident ray and the normal drawn to the point of incidence, right? All of these three, we can draw all of these three within a certain surface. I mean, like within the same A4 sheet, we drew these things without any trouble. That means all of these three lie on a same plane, or else all of these three is going to behave on a certain surface, on a same surface. That's the first and foremost law, my dear children. The other law you already know. What is that? The values of the angle of incidence and the angle of reflection are equal. Always the values of the reflected angle and the incident angle are getting equal to each other. These two are equal to each other. Angle of incidence is equal to angle of reflection. Right. Above conclusions are true for all the instances of reflection of light. Now, my dear children, we took two different instances. In the first instance, we directed a laser beam and we drew out the ray diagram. And my dear children, from that we could observe that these two laws are being satisfied. In the second activity, we took several pins and along the reflection, we point out what's going to happen. Then once again, we complete out the ray diagram by using those reflections. Then, my dear children, once again, we could observe the same thing without any trouble. That means for each and every instance, these two laws are going to happen. Okay, these two laws are going to happen without any trouble. For each and every instance, these laws of reflections can be observed. Okay, that is why these things are referred as laws, because always, all the time, each and every reflection is going to follow up these two contents or these two procedures. Okay, my dear children. Now, these are the two main laws regarding the reflections. Okay, what are the two main laws? When light is reflecting, incident ray, reflected ray and the normal are in the same plane. Then the other thing is that the values of the angle of incidence and the angle of reflection are getting equal to each other. So all of these things are what? All of these two laws are what's going to happen? Those two laws are true for each and every instance or each and every reflection which is going to happen in our day-to-day life. So therefore, my dear children, they are considered as the laws of reflection, right? So these are the ones which are considered as laws of reflection. So my dear children, there are two particular laws of reflection. Okay, there are two laws of reflection. So what are the two laws of reflection then? Number one, incident ray, reflected ray and the normal lie on the same plane. The first law. So let's write down. Incidence ray, reflected ray and normal lie on a same plane. That means on a single surface we can draw all these three rays or all these three straight lines when we are drawing a certain ray diagram. That's why we are mentioning that these three are placed on the same, or else these three are going to behave on the same plane. Okay. Now the second one, right? The second main law. Second main law is also simple. What is that? The angle of incidence is equal to angle of reflection. This is the second law. Angle of incidence is equal to angle of reflection. So angle of incidence, that is the angle between incident ray and the normal. Angle of reflection, it is the angle between normal and the reflected ray. Okay, right. So these are the two laws of reflection. The two laws of reflection. Right then. So now my dear children, we have identified what are the two main laws regarding the reflection. So you know that there are two laws. Always the incident ray, reflected ray and the normal lie on a same plane. The other thing is the angle of reflection is equal to the angle of incidence. Other than that, my dear children, there are no any laws. So each and every reflection is going to follow up these two laws and going to happen in our environment. So are there any different kinds of things related to the reflection process? Of course there are. Now within this lesson part, we are going to study about those two types of reflections. So these two types of reflections are referred as diffuse reflection and the regular reflection, or else in simple we can say that regular reflection and irregular reflection. Okay, so here is given. Let us observe how parallel rays of light are reflected from a smooth surface and a rough surface. Now I told you that if you take a plane mirror is very shiny and it is very smooth. So we are going to study how does the reflection is going to happen from a certain rough surface and from a certain smooth surface. Okay, we are going to study about how it is going to happen. Okay, how the reflection is going to happen. We are going to study how the reflection is going to happen. But here we are using some kind of a smooth surface and also a rough surface in two different instances in order to check like what kind of a reflection process is going to happen in each instance. Okay, then the next one given, let us do the given activity using a plane mirror as a smooth reflecting surface and a crushed aluminium foil as a rough reflecting surface. So here we are going to carry out an activity. Okay, So within this activity, we are going to use a plane mirror as a smooth reflecting surface. Okay. Then we are going to use an aluminium foil as another surface. But however, you know that aluminium foil, now in here it is given within the instructions, it's been crushed. That means the surface is somewhat rough over here. Okay, right then. So now let's head on to see first of all the materials that we need. So here first of all, you know that we'll be needing a laser torch. So laser torch, then a plane mirror, then my dear children, aluminium foil. If you can't find an aluminium foil, you can use even a metallic aluminium surface. However, you know that if you take a metallic surface, it's some kind of rough. Okay, it has some kind of roughness. But however, if you can crush it like here and there, then that would be great. However, if you can find out a metallic surface, metallic aluminium surface, that's also okay, because it has some kind of a rough nature rather than the plane mirror. Okay, or else my dear children, we can use like cardboard sheets wrapped around a aluminium one. Okay, cardboard sheet, you can take a cardboard sheet. Now you can place an aluminium foil around it. Okay, so whatever, okay, you can use any kind of a aluminium foil, a reflective aluminium foil, even a, you know, like when you eat a certain type of a chocolate, right, that chocolate bars also have some kind of an aluminium foil. You can use even those things. Okay, right. So we are going to use a certain rough surface and a smooth surface over here. Okay, right then. So these are the materials that we need to carry out our experiment. Okay, now let's head on to see the method. So method is quite simple, my dear children. What you have to do, you have to direct the laser torch towards the plane mirror, and my dear children, you have to direct the aluminium, you have to direct the torch or else the laser beam towards the aluminium sheet, and you have to observe what is going to happen, right? Okay, so we'll write down the method then. Very simple. Direct the light towards the mirror and observe the reflection. Then in the next point, direct the light towards the aluminium foil and observe the reflection. Right, so pretty much easy. What do you have to do? Direct the light towards the mirror and observe the reflection. First of all, you have to direct the light towards the plane mirror and you have to observe the reflection. Then in the next one, you have to direct the light towards the aluminium foil and observe the reflection. So in two different instances, we are going to direct the light and we are going to observe how does the reflection is going to happen. Okay, this is our activity then. So my dear children, now let's head on to the laboratory. We'll continue the activity over there and let's see what kind of a reflection that we can observe from the plane mirror and from the aluminium foil. So my dear children, with this activity, we'll be observing about how does the reflection is going to happen in a smooth surface and in a rough surface. So I have with me several surfaces. So I have a metallic aluminium surface here right now with me, and this is a aluminium coated one. As you can see here the surface is very rough, and here in this aluminium sheet, within this sheet the surface is somewhat smoother than the previous one. And now I have with me here a plane mirror. As you know that plane mirror has the smoothest surface. Okay, so now let's observe like what kind of a pattern that we can observe after the reflection of light rays in each of these occasions. So in the first occasion or in the first instance, I'll be using a laser box. Here I'll be using several light rays in order to identify the reflection. Okay, right, so this is the laser box now. As you can see, there are now 1, 2, 3, 4, 5 light rays. So now by placing the plane mirror, we'll observe what will happen. So as you can see here the light rays are traveling parallel to the parallel to each other. All the light rays are parallel to each other. So I'll use this laser beam so that you can observe it very clearly. See, these light rays, these ones are parallel to each other. Each of the light rays are parallel to each other. Now let's take the second surface and we'll observe what's going to happen over there. And now in the second surface, my dear children, as you can see, the lines are actually not that much parallel. See, within here you can observe, like in here, this area you can see lines are not that much parallel like in the previous case, right? Now let's use the third one. Right, so as you can see here, now the light rays are actually, we won't be able to observe the lines even, right? So here, as you can see here, the lines are getting scattered here and there. These lines are heavily getting scattered here and there, right? Once again we'll observe, my dear children. See, this is the plane mirror. So it's very clear to us that the plane mirror is reflecting light rays parallel to each other. Then the second one, see, the metal plate, aluminium plate, somewhat parallel. Actually those things are not parallel, but somewhat actually we can see the straight line, like somewhat. Okay, but then the third one, here we won't be able to observe any kind of a straight line because the light rays are scattered here and there, right? Okay, now we'll use the second instrument. I'll keep it over here. Second instrument is a laser light. Okay, so I'll use the laser light first with the mirror. Right, now the case is that we won't be able to observe the light ray which is coming towards the plane mirror in this case because the area is, or our environment is somewhat lightened. So we'll dark the environment and we'll observe what's going to happen. Right, now the environment has darkened, my dear children. Now let's observe the light ray reflection of the laser beam. Right, so as you can see here, the laser beam also getting reflected on a straight line, a clear straight line. Right, now let's observe by using a metal plate. Right, as you can see here, it's getting reflected, but however, like in the previous case, the reflection is not that much not that much getting in a straight line, because here the light rays are getting spreaded somewhat. See, over the point of reflection here, you can clearly observe that the light rays are getting spreaded somewhat. Okay, light rays are getting spreaded somewhat. Once again, we'll use the mirror, my dear children. See, there's a clear difference between the surfaces. Now let's use the third one, the final one. So as you can see here the light rays are getting spreaded here and there. Even we won't be able to observe the line which is passing after the reflection, right? Okay, now we'll use a torch, a flashlight. Right. So this is the pattern that we can observe through a flashlight, my dear children. As you can see, the light rays are getting spreaded here and there. It's getting diffused here and there over the surface. Now let's move on with the plane mirror one. So as you can see here, plane mirror one is giving out a parallel light beam. We can clearly observe the parallel light beam, right? As you can see here now, it's very clear to us that the plane mirror is reflecting the light beams parallel to each other, right? It's very parallel, unlike the previous case. Right, we'll use the third one also, the metallic surface. Here you can see it's showing some kind of a straight line thing, but however those things are not parallel, my dear children, right? So these are the surfaces, my dear children. Right, we'll use the laser beam once more. Check the reflection. So light rays are getting scattered by the surface of aluminium sheet, my dear children. Once again, we'll use the plane mirror. Here the light rays are parallel to each other. Light rays are parallel to each other. It's very clear to us that the light rays are parallel. Then we'll use the third one, the final surface. Here the light rays are getting scattered here and there. Right then. So let's see what are our explanations then. Right, my dear children. Now, what is the reason for having a scattered reflection in this one and within here a clear parallel reflection, and in here somewhat, like it's not actually parallel, but however we can observe some kind of a straight line reflection. It's because that the nature of the surface, my dear children. Now here you know that the surface is very rough, so it is showing a scattered reflection. This scattered reflection is referred as the diffuse reflection. Diffuse reflection. If the surface is somewhat smoother, then we can observe a good reflection like in a plane mirror, my dear children. So that reflection is called the regular reflection, right? The regular reflection. Regular reflection and the scattered or else the diffuse reflection. Right then. So these are the two reflection types that we can observe according to the nature of the surface. When the surface is rough, always we can observe a diffuse reflection, and if the surface is smooth, we can observe a regular or else a parallel reflection. Right then. So let's head on to the classroom once more and we'll observe the other contents in the lesson. Right, my dear children. So we carried out the experiment and you could clearly observe that the light rays are getting scattered. Okay, light rays are getting scattered after the reflection from the aluminium foil. However, when you take the plane mirror, light rays are not getting scattered here and there, but those light rays are light rays are going to travel parallel to each other even after the reflection. Okay, even after the reflection, my dear children, from the plane mirror, light rays are going to travel parallel to each other. Okay, however, after the reflection, through the aluminium foil, the light rays are going to reflect or light rays are going to reflect like in a scattered way, or else light rays are going to scatter and reflect. Okay, right. So we'll write down our observations. So light rays are going to scatter and reflect by the aluminium foil. Light rays are going to scatter and reflect by the aluminium foil. Light rays reflect parallel to each other by the plane mirror. Okay, light rays reflect parallel to each other by the plane mirror. Then light rays are going to scatter and reflect by the aluminium foil. So by the aluminium foil, scatter and reflect. Okay, then by the plane mirror, going to reflect parallel to each other. Okay, so these are the two observations that we can see from the activity. From that, what is the conclusion that we can make? Conclusion is quite simple. Rough surfaces are going to scatter light rays after a reflection. Smooth surfaces are going to reflect light rays parallel to each other. Okay, so we'll write down our observations. Rough surfaces scatter light rays after reflection. Okay, rough surfaces scatter light rays after reflection. So that means over here we can observe the diffuse reflection or else the irregular reflection. Okay, diffuse reflection. Then next one, smooth surfaces reflect light rays parallel to each other. That means, my dear children, we can observe the regular reflection. Right, the regular reflection and the diffuse reflection. So diffuse means the scattering of light rays. Okay, that means it's going to move here and there, not to a certain direction. Then, my dear children, smooth surfaces those things are going to reflect light rays parallel to each other. Okay, so if the light rays are getting scattered, then it is referred as diffuse reflection. Usually rough surfaces are going to do the diffuse reflection. Then my dear children, smooth surfaces are going to reflect, okay, light rays parallel to each other. This is referred as the regular reflection. Okay, regular reflection can be observed in smooth surfaces. So these are the two conclusions that we can take from the activity. Right then. So you may have observed that parallel light rays are reflected parallelly by the plane mirror, and parallel light rays are reflected to various directions by crushed aluminium foil. So that's the conclusion that and the observation that we took from the activity. Okay, so here, according to the activity, it is clear that light reflection is of two types. So by using the activity, we can come into a conclusion that there are two different types of reflections which is going to happen in our environment. So number one is very simple, my dear children. This is called as the regular reflection. Regular reflection. Then the second one, diffuse reflection. Right. Number one is regular reflection. Number two is diffuse reflection. So these are the two main reflection types. So regular reflection, parallel light rays are reflected parallel to each other. Here diffuse reflection, parallel light rays are reflected to various directions, or else they are going to scatter and reflect in diffuse reflection. Okay, right. So two types of reflections. Then my dear children, you are given with the differences that can be observed between diffuse reflection and the parallel reflection, or else the regular reflection. Let's see. Regular reflection. So this is how the regular reflection is going to happen. Parallel light rays going to travel parallel. Okay. Here parallel light rays going to scatter and travel. Diffuse and then regular. Let's see. So when you take the regular reflection, this is done by smooth surfaces. Over there, when we are doing the activity, we could clearly observe that smooth surfaces are not going to scatter light rays, but they are going to pass or reflect light rays parallel to each other. Then over here, regular diffuse reflection or else irregular reflection, here these things or this reflection is carried out by rough surfaces. Okay, this is going to carry out by rough surfaces. The next one, parallel light rays are reflected parallelly. Here, if the light rays which are coming towards the surface is parallel, then after the reflection also they travel parallel to each other. However, the direction which is coming is going to change. Even though the change of direction, the parallelness is not going to change. Okay. Here, at the diffuse reflection, parallel light rays are reflected to various directions. That means those things are getting scattered here and there. As you can see within the figure, you can clearly observe. Here the parallel light rays are traveling here and there. Okay. Those things are not going to travel parallel to each other after the reflection. Okay. Then the next one, example given, reflection of sunlight by a plane mirror. Then for an example, for the smooth or else regular reflection, we can take any kind of a smooth surface like a plane mirror. So plane mirror reflections are regular. Okay, plane mirror reflections are regular. Then the second example given, reflection of a laser rays by a plane mirror. So no matter the light rays, okay, the laser beams are also going to reflect in a regular reflection when they are going to face a plane mirror. Okay, my dear children. So this is the second example for the regular reflection. So irregular reflection or else diffuse. Reflection of sunlight by pages of a book. Now when you observe a book, you know that when you keep the book like this and when you go to an angle and observe, even though you can observe, even though you are observing from a certain angle, you can see the words in the book, letters in the book without any trouble. Okay, it's because that light rays which are coming and falling towards the letter is going to scatter here and there like this. It's not going to travel in the same way like that. It's going to scatter and here and there. Okay, so you can read any kind of a board, any kind of a book, okay, from a certain angle because of this diffuse reflection, my dear children. Because of this diffuse reflection. If the reflection is regular, then my dear children, you will be able to observe these letters and words only from a certain angle. If you go beyond that angle, then you won't be able to observe it, because light rays are going to travel parallel to each other. So on the same line, we have to keep our eyes. Otherwise, you won't be able to observe. However, right, thanks to diffuse reflection, the light rays are going to scatter and travel. Therefore, at any kind of an angle, we can observe the letters in a book. Next one, reflection of sunlight by objects like earth, planets, buildings and rocks. So when you take objects, like any object, okay, in our environment, like it can be a plant, a tree, a building, a person, even massive ones like earth, moon, anything. So all of these things are going to reflect light, okay, according to the diffuse reflection. That's why we can observe these objects at any angle. You know that we can observe the moon from any angle within our planet Earth. It's because that moon is going to scatter light rays, or it is going to do the diffuse reflection. Okay. So to observe objects, my dear children, diffuse reflection is very important. We won't be able to observe objects, right, by different angles if objects are going to reflect parallel to each other, or else if the objects are going to show regular reflection, right? So thanks to diffuse reflection, we can observe objects at any angle. Okay, so these are the differences between diffuse reflection and, my dear children, the regular reflection. Right then, so now you are given with another point over here. See, you are given with another point about the regular reflection and the diffuse reflection. Think whether regular reflection or diffuse reflection is commonly found in day-to-day life. Both regular reflection and diffuse reflection are useful in day-to-day life. So you are given with the instances where regular reflection is useful. What are the instances? Let's see. Regular reflection is commonly found when used in mirrors. So when used in mirrors, my dear children, we can identify the regular reflection. So example, to watch one's own face, to use light microscope. Okay. So in order to observe our own face, we have to face it towards a plane mirror. No. In that case, my dear children, the regular reflection is going to happen. Otherwise, what will happen? Otherwise, my dear children, the face will be, like changed if the diffuse reflection is going to happen. And the other instance is that to use the light microscope. So over the light microscope, you know that light is going to come like here, then travel through the regular reflection towards a, right, towards a observer, towards the eye of the observer. If the light rays are going to diffuse here and there like this, then we won't be able to observe the specimen clearly. So thanks to regular reflection, light rays are going to come like this and going to travel through the specimen towards the eye. So we can clearly observe the specimen, right, within the microscope thanks to this regular reflection. Okay, so these are the instances where we use, or these are the benefits of regular reflection. Then the third one, to get vivid information, to create vivid light patterns in various shows. You know, like in magic shows and some entertainment shows, we use these kinds of vivid patterns, right, on the stage. So these vivid patterns are getting created thanks to regular reflection. Then the next one given, to get information of the motion of machine parts in industrial plants. So in several industrial plants, my dear children, to get the information of certain machinery parts, to observe whether the machinery part is working on a straight line or not, to observe whether the machine part is rotating along the same circular pathway or not, we can use the regular reflection. Okay, right. So these are the benefits of regular reflection then, right, my dear children. Now let's head on to see what are the importance of irregular or else diffuse reflection. So here you are given with a point. So first of all, we'll write down the topic of the point. So what is the topic? We are going to discuss what are the importance or what are the usefulness of irregular or else diffuse reflection. So we'll write down the topic first. Uses of diffuse reflection. Uses of diffuse reflection. So like I said, my dear children, to observe objects. Now here you can observe there is a plant. So the parallel light rays which are coming from the sun is going to hit on this plant and going to travel in various directions like this, here and there. So we can observe this particular plant at any angle. So in order to observe objects, this diffuse reflection is very much important, pretty much important. So here is given, objects in the environment can be seen from all directions as they reflect sunlight diffusely. So because of the diffuse reflection, we can observe objects at any angle, at any direction, my dear children. This thing is going to happen mainly because of the diffuse reflection. If the diffuse reflection is not going to happen from a certain object, then we won't be able to observe that object from each and every angle to each and every direction. We can only observe that one from a particular angle, only from a particular direction on. Okay. So my dear children, diffuse reflection is quite important to observe objects. Then the other thing, as you can see, here there is a kid who is reading the book. Even when I'm over here, I can clearly observe the thing which is over the page. I can clearly observe a melon, a watermelon. See, I can clearly observe the picture. Why is that? From here I can observe. Even from here I can observe. Even from this kind of an angle, I can observe it. Okay. Even from here, like when I'm facing directly, in that case also I can observe the figure within the book. Why is that? It's because that, my dear children, when I'm over here, light rays is going to come and hit on the object and travel to this direction. When I'm going to place it like this, when I'm going to stand like this kind of a direction. See, like this kind of a direction. When I'm going to stand like this, then like this kind of a direction. So as you can see, here the light rays are getting scattered here and there to this direction, that direction, everywhere. So we can read books thanks to this diffuse reflection because the light rays are getting scattered here and there. So here is given, letters in a book can be seen from all directions because of the diffuse reflection. So my dear children, here we discussed about the uses of diffuse reflection. The diffuse reflection. So diffuse reflection is very important to observe objects and also to observe letters in a book. Okay, so these are the uses of diffuse reflection and the regular reflection. Okay, right, my dear children. Now I think you got a good idea about the diffuse reflection and the regular reflection, okay, and their uses as well. Right then, now let's head on to see the next content. So you are given with an assignment. Let's see. Discuss in the classroom the instances where regular reflection and diffuse reflection are useful. Tabulate the facts you discussed. Okay, so you have to tabulate about the regular reflections, uses of regular reflections, and the uses of diffuse reflections, my dear children. Okay, but here specially they are given, right, in the classroom. You have to find out what are the instances where regular and diffuse reflections are useful. Okay, right. So as you know, these assignments are for you guys. So you guys have to fill out these things and to find out these things. Okay, it's important to do these assignments, my dear children. So by following these assignments, you'll be able to replenish your knowledge, right? You'll be able to replenish your knowledge even more. That's the whole idea of giving a certain assignment. So it's your responsibility, a main responsibility, to follow out these assignments and to do these assignments at your home or in your classrooms, my dear children. Okay, so to provide you a certain guide, I'll be writing down two different uses of these regular reflections and the diffuse reflections, my dear children. Okay, so we'll tabulate this thing then. First of all, then we'll take down a table like this. Okay, so I'm going to write down only two. So guys have to find out even more. So I'll be writing down two uses of regular reflection and two uses of irregular or diffuse reflection, right? So here regular, here diffuse. Regular, number one, to observe using microscope. Then, my dear children, you know that certain astronauts, and my dear children, certain scientists, even I think some of you guys have certain experience about using a telescope. How we can observe by using a telescope, my dear children? Within the telescope also, the light rays are going to travel parallel to they are coming parallel and going to travel in the same parallel direction. If those things are going to scatter here and there, then my dear children, what will happen? Then you will be able to observe without placing the eye on that certain point of the telescope. Okay, so within the telescope also, right, telescope also, this regular reflection is quite important. Okay, so to observe those craters and all the other things contained within a planet, or else within a star, okay, or else within any celestial object, right? The regular reflection given out by the telescope is very important. Okay, so the second one would be to observe To observe using telescope. To observe using telescope, right? To observe using telescope also, this regular reflection is important. Then, my dear children, diffuse reflection. You know, to observe objects, right? Diffuse reflection is very important. That means, in order to learn and to do our studies, this thing is very important, right? So, in reading and writing and learning, this diffuse reflection or irregular reflection is very important. So, we can write in studying, within brackets, observe letters. Observe letters. Okay. Then my dear children, in playing, to observe objects like balls, bats. So you know that I think most of you guys have the experience of playing cricket. So in order to catch a ball, you are running towards the ball, no? Okay. So no matter you are filled in position, you can see the ball without any trouble. It's because of the diffuse reflection. So when you are playing cricket or any kind of another sport, the balls or the objects can be clearly visible, or those things are clearly visible to us, mainly because of the diffuse reflection, my dear children. If there is no diffuse reflection, then my dear children, you can observe only at a certain angle. However, you know that when you take a certain player, right, who is standing on a ground, if a certain batsman in cricket, okay, if a certain batsman is going to hit a ball in the air, then my dear children, the fielder can run and jump and catch the ball without any trouble, no matter the position of the fielder. It's mainly because of the diffuse reflection given out by the surface of the ball, right? Light rays are going to scatter here and there. So almost all the fielders within the ground can observe the ball without any trouble, right? So these are the users in our day-to-day life where the diffuse reflection and the regular reflection is important. Okay, so actually diffuse reflection is the most important one, my dear children. Otherwise we won't be able to observe any kind of an object. Okay, you can observe but at a certain angle, not from all the directions, right? So I hope that you got an idea about the diffuse reflection and the regular reflection and of their uses as well. So here I have tabulated only two. Okay, here I have tabulated only two users. So like I said, it's very important to follow out these assignments at your home or classroom, then find out even more details. I'm just giving out a guide in doing these assignments. Okay, my dear children, right? So regular reflections can be used for observing specimens through microscope. Then, my dear children, to observe planets and other celestial objects by using the telescope. The diffuse reflection in our studying to observe letters and other things, diffuse reflection is important. Then, my dear children, in playing also we need to observe objects. So in playing to observe objects like balls and bats, the diffuse reflection is very important. Okay, right then. So these are the two types of reflections about the diffuse reflection and the regular reflection. So I hope that you got a good idea about the reflection process. Right, my dear children. So with that part, I'm going to finish up the second chapter. So within our next chapter, we'll discuss further things related to our lesson part, reflection of waves. Okay, reflection of waves. Here especially within the next chapter also, we'll be discussing about the reflection of light waves.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.